Good evening, students. Today my topic is electronic configuration. By now you have learned about the basic structure of an atom, which is quite similar to the structure of the solar system. You must be knowing that an atom is majorly made up of three subatomic particles, which are negatively charged electrons, positively charged particles protons, and neutral neutrons. Now in an atom there are two parts. One is the nucleus, which is present at the center of the atom, just like the sun present at the center of the solar system. And this nucleus is made up of two subatomic particles, which are protons and neutrons. And that is why these two subatomic particles, protons and neutrons, together are called nucleons, as they are the particles of the nucleus. And because of the presence of the positively charged particles, protons, in the nucleus, the charge of the nucleus is also positive. Other part of the atom is the extranuclear part, that is the part which is outside the nucleus. And you can see these are the extranuclear parts, which are also called energy shells or orbits. Now the third subatomic particles, that is electrons, are present in these orbits or energy shells. And the way planets are revolving around the sun in different orbits in the solar system, similarly, electrons are revolving around the sun-like nucleus in different orbits at a very high speed in an atom. Now, in this video, we are only concerned about the electrons and how these electrons are arranged or distributed in different energy shells or orbit around the nucleus in an atom. And this arrangement or distribution of electrons in different shells or orbits around the nucleus in an atom is called electronic configuration. So, electronic configuration can be defined as the arrangement or distribution of electrons in the different energy shells or orbit around the nucleus in an atom. So, you must remember two things from here. One is that the negatively charged subatomic particle electrons are present in different energy shells around the nucleus in an atom, and the arrangement of these electrons in those energy shells and orbit called electronic configuration. Now, regarding electronic configuration, you have to learn one rule, which is called Bohr-Bury rule. Now, what does this rule tells us? This rule tells us about the capacity of an energy shell or orbit. Capacity means you can say the capability of a shell to hold or accommodate electrons. Okay. Each shell will have obviously different capacity based on the size of the shell. Now, before I start explaining Bohr-Bury rules, let me tell you the names of the different energy shells or orbit. Now, the shell which is closest to the nucleus is called the first shell and named as K shell. This shell is also known as innermost shell. Now, the shell that is next to K shell, that is the second shell, is named as L shell. The third shell which is next to L shell is named as M shell, and the fourth shell which is next to M shell is named as N shell. So, this is how the name of the shells were given, K, L, M, N. And the number of shell is denoted by the symbol N. Okay, so when n is equal to 1, we are talking about the first shell, and similarly when n is equal to 2, 3, 4, we are talking about second, third and fourth shells respectively. Now, the shell which is closest to the nucleus, obviously K shell we are talking about, that shell has the smallest size and therefore the capacity of the shell will be least, whereas as we move further from the nucleus, the size of the shell increases, and according to the capacity to hold or accommodate electron also increases. Now, Bohr-Bury rule, there are two rules actually. The first rule tells us that the maximum number of electrons that can be accommodated in a shell is given by 2n square formula. Okay, first of all, the maximum number of electrons a shell can have. That means the maximum capacity of a shell has to be calculated, and that can be calculated by the formula 2n square. Now this can be explained with a suitable example, like suppose you have gone to a hotel and there are some rooms 1, 2, 3, 4 like this. Now in room number 1, suppose maximum 2 people can stay, okay, whereas in room number 2 8 people can stay, which means obviously the size of the second room is larger than the size of the first room, and that is why more people can accommodate in the second room as compared to the first room. Okay, so similarly here also, according to or based on the size of the shells, it will be determined that how many electrons they can accommodate, maximum how many electrons they can accommodate. Okay, and these can be calculated by 2n square rule, where n is equal to number of shell. Now if you put n is equal to 1, what will you get? 1 square into 2, that is 2. It means the first shell, that is K shell or the innermost shell, can accommodate maximum 2 electrons in it, whereas the second shell, that is L shell, can accommodate maximum 8 electrons in it, and similarly third and fourth shell, that is M and L shell, can accommodate maximum 18 and 32 electrons in it. And how to calculate these numbers? Just putting n is equal to 2, 3, 4 like this. Okay, so from this formula we are getting that the capacity of holding electrons by these shells, that means the maximum capacity of K shell is 2, which means less than 2 electrons can be accommodated in K shell but not more than 2. So L shell can also accommodate less than 8 electrons but not more than 8. Similarly, M and N can also accommodate less than 18 and 32 electrons respectively but not more than these electrons. Okay, so that's all about the first rule of Bohr-Bury rules, which is the maximum number of electrons that a shell can accommodate can be calculated by the formula 2n square, where n is equal to number of shell. And according to this formula, K, L, M and shells can accommodate maximum 2, 8, 18, 32 electrons respectively. Now the second rule is the outermost or valence shell of an atom cannot have more than 8 electrons in any case. What does it mean? It means that the last shell, whatever may be the last shell, L, M, N of a particular atom, that shell cannot have more than 8 electrons at a time. Now if K shell is present as the last shell, then this rule is not applicable for that shell, because you can see that according to the first rule of Bohr-Bury, that the K shell can accommodate maximum 2 electrons only, so it is not possible for K shell to hold more than 2 electrons. So therefore this rule is obviously not applicable for K shell as the last shell. But if L, M, N are the last shell of a particular atom, then obviously this rule is applicable. So whatever may be the last shell for a particular atom, L, M, N, whatever, that shell cannot accommodate more than 8 electrons at a time. Now you can ask why M and N shell can accommodate more than 8 electrons, that is 18 and 32 electrons respectively. But yes, they can accommodate 18 and 32 electrons but not at a time. At a time, for a particular atom, if they are the last shell, then also they can accommodate maximum 8 electrons at a time. This is the second rule of Bohr-Bury. Now, these according to these rules, suppose you have M and N as the last shell, then if M shell or N shell are filled with 8 electrons already, and then also some more electrons are present in the atom, then obviously those electrons will be going to the next shell. That's all about Bohr-Bury rule. I hope you have understood the concept of electronic configuration properly, and the second rule you will be able to understand better in the next video, where I will discuss the electronic configuration of different atoms. So that's all for today. Thank you.